इसमें एक अच्छा स्टैंड
आदिल सर झालं ना? ओके.
हाँ सर, हाँ सर, अभी आप
Yes,
मुझे
yes.
कर लूँ, मैं रिक्लेम कर लूँ?
काय हो हो सर, हो झालाय हो लाईव्ह स्ट्रीम. ओके
ओके सर, करून घेतो मी
यस
reclaim.
यस सर, यस सर. पाठवलं का तुम्ही?
सर आप काम करो, मेरे को आप होस्ट, हाँ ठीक है, मैं हो गया हूँ होस्ट अभी. ठीक है
यस सर.
सर, अभी मैं होस्ट हूँ अभी. ओके, तो अभी पार्टिसिपेंट के लिए अपन ने ओपन नहीं किया, अपन 5-10 मिनट 5-7 मिनट बाद ओपन करेंगे पार्टिसिपेंट्स के लिए. ठीक है गंधारे सर?
यस सर.
आप चेक कर लो अपना ऑडियो वीडियो,
ओके सर.
एक बार चेक कर लो सर.
हाँ ठीक है सर. अभी
हाँ, ये आपके पास डिस्टरबेंस क्या है आजू बाजू? और
जादव सर है.
जादव सर को बोलो दूसरे रूम में बैठिए प्लीज करके.
ओके ओके.
है ना, क्योंकि एक रूम में अलग अलग लोग बैठेंगे तो फिर इको नहीं होगा.
ठीक ठीक है.
ठीक है, अभी भी थोड़ा इको आ रहा है आपकी वॉइस में, हो जाएगा लेकिन वो.
ठीक ठीक.
ठीक है. गंधारे सर?
यस सर.
आपके पास इंटरनेट का एक और ऑप्शन रखिएगा.
ठीक है सर.
ये जो इंटरनेट दिख रहा है, इसकी बैंडविड्थ लो दिख रही है.
ओके सर. ओके.
एक अल्टरनेट ऑप्शन रखिएगा प्लीज.
ओके सर.
हाँ, आप लोग भी चेक कर लो. तृप्ति मैम,
हाँ
ऑडियो और वीडियो चेक कर लीजिए आप प्लीज.
ओके.
ठीक है, वॉइस.
गुड मॉर्निंग सर.
गुड मॉर्निंग मैम, वॉइस इज क्लियर, वीडियो इज क्लियर, नो प्रॉब्लम.
ओके.
ओके ओके. सर का ईमेल उसमें ओपन करना पड़ेगा, ईमेल ओपन करना पड़ेगा सर. फिर उसमें लिंक है, गूगल पे जाके. प्रवीण सर?
हाँ बोलिए सर.
ओके, ऑडियो वीडियो?
हाँ एकदम ओके सर.
ठीक है. तो उन्होंने उधर यूट्यूब तो लाइव उन्होंने कर दिया गुरनुले सर ने.
अरे वाह सर, लिंक आ गई.
लिंक अपने को तो ग्रुप पे डालेंगे वो लोग, अपने को तो काम नहीं है वो लिंक का फिलहाल.
हाँ ठीक है सर.
आ जाएगी, गंधारे सर दे देंगे अपने.
हाँ सर, ग्रुप में डाला हूँ मैं लिंक.
ठीक है ठीक है. ओके ओके.
ठीक है सर.
गंधारे सर?
यस सर.
अपने इनॉग्रल प्रोग्राम में जो की पीपल है वो कितने लोग हैं एकदम, जो लोग को आप स्क्रीन पे रखना चाहोगे इनॉग्रल प्रोग्राम में?
6 लोग रहेंगे सर अपने.
अच्छा, जैसे डॉक्टर राजू देशमुख साहब जुड़ने वाले हैं, नवीन सर भी ज्वाइन होने वाले 2 मिनट में.
हाँ.
आप रहोगे, उसके अलावा और कौन रहेंगे? गुरनुले सर रहेंगे.
गुरु सर और स्पीकर रहेंगे.
तो मुझे बताइएगा थोड़ा सा आप फिर बीच में जब भी ऐसा लगा तो. देशमुख सर
हाँ,
टेस्ट कर रहे हैं, राजू देशमुख सर.
हाँ ओके.
गुड मॉर्निंग डॉक्टर देशमुख सर.
गुड मॉर्निंग सर.
गुड मॉर्निंग सर.
ऑडियो कनेक्ट होने का है डॉक्टर देशमुख सर का. कर रहे कनेक्ट. गुड मॉर्निंग डॉक्टर राजू देशमुख सर.
Good morning. Good morning.
President sir, am I audible to you? Raju Deshmukh sir? Sir, actually, we are not able to hear you.
ऑन है ना. हेलो हेलो जीवानी,
सर अभी आपकी आवाज आ रही है क्लियर सर.
आ रही ना?
आ रही है सर क्लियर अभी.
ओके.
सर एक आप बने रहेंगे 11:05 के अराउंड चालू होगा तो आप बने रहेंगे तब तक सर कि आप वापस से ज्वाइन करोगे?
मैं बने ही रहता हूँ क्योंकि मैं नहीं तो फिर करीब
11:05 से पहले अपन स्टार्ट करेंगे सर.
10 मिनट के बाद में ज्वाइन करूंगा.
हाँ सर चलेगा. अपन ने पार्टिसिपेंट को 11 का टाइम दिया है सर.
ओके
तो
ठीक
अपन स्टार्ट कर देंगे 11:05 पे राइट टाइम एकदम.
ठीक है.
2 या 3 मिनट में 11 के. हाँ सर. ओके सर. थँक यू सो मच सर.
होना चाहिए बरोबर. प्रशांत तू लक्ष ठेवशील ना?
इथून फक्त अनम्यूट होतं सर, बाकी काहीच नाही. म्यूट अनम्यूट असं काहीच नाही. काय होतं?
तर आपण 15 मिनिटं वेळ आहे त्याला. ठीक आहे
चालेल.
अरे आदिल थोड़ा सा इसको देखो, ये क्या हो रहा है, हम ज्वाइन क्यों नहीं हो रहे?
सर इथे झेरॉक्स आहे.
ते असं की मला जर वाटलं किंवा याचा रूम बघायचा आहे अकाउंट, तर मला बटन दाबून आलं पाहिजे. टाका काय. आणि हे जे आहेत ना, हे जिकडे तिकडचे अरे हो, लेकिन मेरे को पता नहीं था ना ऐसा कैसे करना करके.
वो तो मैं कर रहा था ना, मेरी बात हुई ना वहाँ के आईटी वाले से.
हो गया.
एक भी उसने लीव करने बोला.
हो गया ना सर. आप ज्वाइन हो प्रॉपरली.
तो 11:05 पे हम रहेंगे तो करा दो.
हाँ ठीक है. अभी वेट भी आपको जो कंफर्टेबल है सर को वैसे कर सकते हैं.
ठीक है. एक सर को मैं हेडफोन्स दूंगा.
हाँ
ताकि उनको वॉइस क्लियर आए.
ठीक है. आपको जो कंफर्टेबल है.
ठीक है, क्योंकि वो बात जब करेंगे ना तो हो सकता है कि यहाँ पे डिस्टॉर्शन रहे, तो एक हेडफोन लगा के मैं कराऊंगा.
हाँ ठीक है. ओके.
1 घंटे बाद भेजिएगा.
अभी मैं हेलो.
हाँ सर बोलिए.
रखूँ क्या कि
ज्वाइन ही रखिए ना सर. अभी 2-4 मिनट 10 मिनट की बात है.
क्या
देना.
ये ऑडियो टेस्ट कैसे होगा हमारा?
ऑडियो आ रहा है सर आपका.
ये करना पड़ेगा.
निकाल दो सर. ऑडियो चालू है.
हेलो आदिल,
ऑडिबल.
ये हाँ ऑडिबल है. आप उधर बैठे
ठीक है सर.
अरे भैया थैंक यू. घर में बैठा इसका भैया कर लेना.
गुरमिलो साहब, गुड मॉर्निंग.
गुड
गुड
मॉर्निंग.
मॉर्निंग.
Good morning, sir.
गुड मॉर्निंग.
और कैसे है सर?
डॉक्टर साहब ज्वाइन हुए थे ना?
नवीन सर, हाउ आर यू?
हाँ, आई एम फाइन, आई एम फाइन.
ओके.
डॉक्टर साहब ज्वाइन है नवीन सर.
सर, गुड मॉर्निंग सर.
गुड मॉर्निंग. गुड मॉर्निंग.
Good morning. Thank you, sir, for joining.
Yeah, I'm in time.
Okay, thank you.
What am I supposed to do?
I mean, you have to address the audience, you see, as chairman of the inaugural function.
Okay.
Okay.
What is the subject? Chemistry.
Subject is recent advances. Recent advances in physical, chemical, and biological sciences.
Okay. Recent advances in chemical, physical, and biological.
नवीन सर, गंधारे सर को अटेंडीज में से पैनलिस्ट में लो प्लीज.
ओके सर.
ठीक है ना? हमने किया बेटा. हमने भी नहीं. ठीक.
Dr. Giovanni.
Yes sir.
Hello, Dr. Giovanni.
Yes sir.
All outside guests have joined.
They are joining sir. Gurnule sir is there and other people among our guests are yet to join.
Hello.
I mean, our guest of honor from Mauritius, Gurnule Sahab, he has joined.
Oh, yeah.
Gurnule sir is there sir.
No, Mauritius professor has not joined till. Okay.
He's joining, no?
I'm waiting. Yeah, I'm waiting for him.
Sir, is my
Okay,
voice
okay.
audible? Is my voice audible?
Yes, yes.
Deshmukh sir, voice is audible? Hello?
Yes, it is audible sir, properly audible.
Okay, fine. Then no need of mic.
It will be fine without mic even.
Okay, fine.
No, I'm there. I'm very much there. Yeah. Good morning.
Good morning. Good morning.
Why it is showing Professor W.B. Gurnule? It is showing your name. No problem.
Sir,
No problem. Yeah.
we can rename that anytime sir.
Yeah. It can be renamed. Yeah.
You might have used Gurnule sir's email ID. That is why it is Gurnule sir's link. That is why it is showing.
Yeah. He sent me and then I clicked it and yeah. No
Okay,
problem.
Sir, please rename yourself.
Okay.
Professor Swaminathan Sahab has joined. Gurnule Sahab. Gurnule Sahab, please unmute yourself.
Yes, I'm calling to Swaminathan. Yeah.
Yeah. And Professor Nagarajan from Tiruvarur.
Sir is joining tomorrow. Okay. The sir's talk is tomorrow is their talk. Okay. Sir is busy
Okay.
in some committee today in the university.
Okay. Okay, fine. देशमुख सर, अब अपने डॉक्टर गुरनुले फ्रॉम कमला नेहरू महाविद्यालय नागपुर.
अच्छा अच्छा.
He has helped a lot, you see, in order to get this e-conference, international e-conference organized
Very nice.
by our college.
Very good.
Yeah.
Very good. This is the greatness of science and
Yeah.
a human vision that all over the world people can get on a platform without moving their seat and talk to each other
Yes, sir.
and
Yes.
and give the knowledge to each other, spread it worldwide. That is how
Yes, sir.
things are. We are thankful to God for all this. Thanks.
Yes. And Dr. Gandhare from Postgraduate Department of Chemistry of our college.
Good morning. Good morning,
has
sir.
taken a lot of topics, you see, to see that this e-conference is organized today and tomorrow.
नेक्स्ट मैडम प्लीज चेक
On
योर ऑडियो.
हाँ सर. जी सर
ऑडियो
बोलिए.
और वीडियो प्रॉपर है आपका. सॉरी
hello,
नवीन
sir.
सर टू इंटरप्ट.
Professor Pare sir. Again, the name is not changed, huh?
मुझे बता दीजिए, मैं चेंज करता हूँ सर. क्या नाम लिखना है वो
Adil sir.
बताइए.
हाँ,
हाँ
Professor
बताइए.
Brijesh Pare.
प्रोफेसर
अरे
Brijesh,
ब्रिजेश. ठीक है सर. ओके.
make do the correction. Yeah.
डॉक्टर साहब एक चीज और बोलना चाहता हूँ. On 1st of July, a committee is coming for granting us research centers for the Department of Chemistry and English.
उजेडच नाही येत आहे.
ब्रिजेश परे बोले ना सर आपने. गुरनुले सर.
Oh, here, here, here.
PARE.
म्हणजे चेहऱ्यावर उजेड नाही येत आहे. तिकडे बसू का?
Yes, now it's okay, sir. Pare sir, unmute yourself. Pare sir.
मला काहीतरी पाहिजे ज्याच्यावर
Yeah,
मी
yeah,
याला
it's okay.
play करते.
Yeah,
Naveen sir, Professor Brijesh Pare is the chief guest of today's program,
yeah.
and sir is the president of the ACT, Association of Chemistry Teacher. Yeah.
Thank you.
So नवीन सर. नवीन सर. नवीन सर प्लीज अनम्यूट योरसेल्फ. नवीन सर.
Pare sir.
Yes.
Dr. DV Prabhu has not joined.
Ah,
Yesterday,
yeah. I
yeah.
read his email. He
Yeah,
is
yeah.
away. Probably he is occupied and he's not joining. No problem. Yeah.
Yeah. Yes.
नवीन सर.
हाँ जी.
हम रेडी है. Our participants have joined. Our guests are there. Our honorable president Saab is there. So please guide us further.
Okay.
It is 11 o'clock.
And if everything is ready, we can start.
नीलेश गंधारे सर.
Yes, sir.
रेडी है अपनी सब चीजें. स्टार्ट कर सकते हैं.
हाँ रेडी है मैडम. रीना मैडम.
रीना मैडम प्लीज टर्न ऑन कैमरा एंड ऑडियो.
Jivani sir, I am audible.
यस सर, यू आर ऑडिबल सर. यस सर.
सर आपने मुझे डिसेबल करके रखा है. आई कैन नॉट स्टार्ट माय कैमरा.
जस्ट अ सेकंड मैम. ट्राई कीजिए मैम अभी.
हाँ ठीक है.
ठीक है
Okay.
मैम. ओके मैम.
We can
कैन वी
start.
स्टार्ट?
Yes.
सर आप 3 तक बोलिए. देन आई कैन स्टार्ट. आई विल स्टार्ट.
प्लीज
मेरी आवाज क्लियर आ रही है सर?
क्लियर है, क्लियर है,
Yes.
प्लीज गो अहेड।
जी,
Start, madam.
yeah. Honorable dignitaries, learned delegates, respected teachers, and dear students, a very good morning to one and all. We wish you all a good health and healthy environment in this pandemic situation. I, Dr. Reena Meshram, on behalf of the Department of Chemistry, Nabira Mahavidyalaya Katol, and Association of Chemistry Teachers, that is ACT, Mumbai, welcome you all in International E-Conference on recent advances in chemical, physical, and biological sciences. Respected participants, before moving ahead, it's an humble request to one and all to please mute your audio. We are here for 2 days to drown into the sea of knowledge and come up with different new ideas to explore the world with different renowned faculties which we have 2 days with us. Well, with a great thought which was given by the Albert Einstein, he said that if we knew what was we were doing, it would not be called research, would it? It is on occasion like this we get opportunities to test our knowledge and understanding. So such events or platforms are an exposure to what the best is going on the dynamic issues of recent advances in chemical, physical, and biological sciences. So, before we start the inaugural session, let me pay my homage to Honorable late Shri Bhikulalji Nabira, founder of Nabira Mahavidyalaya Katol, Nagpur. I also acknowledge the patronage of Honorable Dr. Rajuji Deshmukh Sir, President Shikshan Prasarak Mandal Katol, Shri Niranjanji Rao, Vice President Shikshan Prasarak Mandal Katol, Shri Bansilalji Nabira, Secretary, Shikshan Prasarak Mandal Katol, Shri Prakashji Chandak, Treasurer, Shikshan Prasarak Mandal Katol. I have got privilege to welcome Honorable Dr. Rajuji Deshmukh Sir, President Shikshan Prasarak Mandal Katol. I also welcome our chief guest of our 2-day international conference, Dr. Brijesh Pare Sir, President ACT and Professor and Head, Department of Chemistry, Madhav Science PG College, Ujjain. I am immensely delighted to welcome, sorry, he is not today in program. Further, I extend our sincere welcome to enthusiastic and dynamic personality of our institute, Dr. Sunil Kumar Naveen Sir, Principal Nabira Mahavidyalaya Katol. I am very pleased to welcome Dr. A.D. Borkar Sir, Head and Professor, Department of Chemistry, Nabira Mahavidyalaya Katol. I also welcome Dr. Nilesh Gandhare, convener of 2-day International E-Conference and Assistant Professor, Nabira Mahavidyalaya Katol. With these words, friends, I welcome all the distinguished guests of the inaugural and technical sessions. I must acknowledge all participants for this overwhelming response which we get for this international conference. I welcome all academicians and researchers who have registered for this 2-day international e-conference on recent advances in chemical, physical, and biological sciences. So further, to move ahead, I request Dr. Nilesh Gandhare, convener of this international conference, for his welcome address. Dr. Nilesh Gandhare, sir, over to you.
Thank you, ma'am. Good morning to all of you. On behalf of organizing committee, I welcome all the resource persons, academicians, and participants for this 2 days international e-conference on recent advances in chemical, physical, and biological sciences, organized by Department of Chemistry, Nabira Mahavidyalaya Katol, and Association of Chemistry Teachers. Honorable Dr. Raju Deshmukh, President Shikshan Prasarak Mandal Katol, President of today's inaugural session, Chief Guest Honorable Professor Brijesh Pare, President ACT and Professor and Head Department of Chemistry, Madhav Science PG College, Ujjain. Principal of our college, Dr. S.K. Naveen Sir, Head of Department of Chemistry, Professor A.D. Borkar sir, Dr. Gurnale sir, respected speakers, and dear participants from the globe and from various parts of country. For the inauguration, Honorable Dr. Raju Deshmukh, President, Shikshan Prasarak Mandal Katol, sir has been kind enough to have spared his valuable time and to be present here. We are highly obliged to you, sir. I offer a warm welcome on behalf of organizing committee. For the inauguration, chief guest, Honorable Professor B.J. Pare, President ACT and Professor and Head Department of Chemistry, Madhav Science PG College, Ujjain. Sir has been kind enough to have spared the valuable time and to be present here. I offer a warm welcome on behalf of organizing committee. This international conference aims to promote the interaction of researchers and sharing of ideas, expertise, experience in the recent advances in chemical, physical, and biological sciences, while providing opportunities to discuss recent and new findings. Students and researchers will get exposures and gain insight into interdisciplinary research. This interdisciplinary research oriented conference is very important for recent graduates and academicians. Nowadays, chemical science emerges as a basic and latest tool for all kind of technical research, education, and allied subjective collaborative work among various leading branches of the science. This conference would serve as a common platform for participation of experts from industry, academia, and research organization, and would provide a knowledge sharing pedestal to an insight into the current scenario and technological advancement in their concerned field. The main objective of organizing 2 days international e-conference on recent advances in chemical, physical, and biological science is presentation of current research, the latest technologies being adapted to address local and international challenges, creating an international forum for academics, researchers, and scientists from worldwide, results and proposal regarding soundless issues related to chemistry, physics, and biology. Therefore, this 2 days international e-conference will be definitely beneficial to participants in their field. For this 2 days international e-conference, around 4,335 participants have registered from 24 different countries like Nigeria, Philippines, Bangladesh, Tunisia, Egypt, Pakistan, Oman, Nepal, Indonesia, Malaysia, Ethiopia, South Korea, Iraq, UK, Sri Lanka, UAE, Mexico, Tanzania, Libya, Iran, Saudi Arabia, Uganda, France, and China, and almost all states of India. So I welcome you all on this occasion. We have an opportunity to be benefited by the talks of Professor Ponnaduria Ramaswamy, Department of Chemistry, Faculty of Science, University of Mauritius, Republic of Mauritius. Dr. Kiran Kumar Surati, Associate Professor, Department of Chemistry, SP University, Anand, Gujarat. Professor S. Nagarajan, Dean School of Basic and Applied Science, Department of Chemistry, Central University of Tamil Nadu, Tirunelveli. Professor M. Swaminathan, Nanomaterial Laboratory, International Research Center, Department of Chemistry, Kalasinga, Academic Research of Education, Krishna Koli. Professor W. B. Gurnale, Department of Chemistry, Kamla Nehru Mahavidyalaya, Nagpur. At last, as a convener of 2 days international e-conference, I welcome all the resource persons, speakers, academicians, and participants. Thank you. Over to you, ma'am.
Thank you, Dr. Nilesh Gandhare, for giving us the insight of the objectives of this international conference. Now, I request our respected principal, Sir, Dr. Sunil Kumar Naveen, to deliver his introductory remarks. Over to you, sir.
Thank you, Dr. Reena. Honorable President, Shikshan Prasarak Mandal Katol, and Chairman of today's two-day International Virtual Conference, Dr. Rajuji Deshmukh, esteemed and honorable members of the management, Sri Niranjanji Raut, Sri Bansilalji Nabira, Sri Yogeshji Pandey, Sri Prakashji Chandak, Sri Purushottamji Mankar, honorable guest of honor, Professor D.B. Prabhu, General Secretary, Association of Chemistry Teachers, Wilson College, Mumbai, Chief Guest, Professor Brijesh Pare, President, Association of Chemistry Teachers, and Professor and Head, Madhav Science PG College, Ujjain, resource persons, Dr. Ponna Durai from Mauritius, Dr. Kiran Kumar Surati from Anand, Gujarat, Professor Nagarajan Tiruvarur, Tamil Nadu, Professor Swaminathan from Krishnan Koli, and Professor Gurnule from Kamala Nehru College, Nagpur, Dr. Gandhare from Postgraduate Department of Chemistry of our college, Dr. Borkar, Head Department of Chemistry of our college, distinguished participant, delegates from across various nations, 24 nations of the world, researchers, my fellow colleagues, and student friends. The way we interact with nature, the way man interacts with man, the way man interacts with the universe has been defined by science since ages. Today, the way research and development is taking place in the field of science and technology has changed the way we consume knowledge. Science can be defined as the human endeavor to understand the behavior of nature by observation and experiment, by systematic analysis of general rules, general laws, and principles of nature. Technology, on the other hand, is the application of science for practical purposes. Science and its applications, man has been harnessing to make human life easier and better. Fine. We have terribly succeeded in increasing life expectancy with modern medicines and complex surgical operations. The invention of bionic is used in limbs and eyes. Bionic limb allows handicapped persons with technology-enabled limbs, which can also perform movements. Similarly, bionic eyes allow a blind person to see the world with the help of computer chips. We have brought about a mind-boggling revolution in the field of transport and radio communication. The use of internet has truly revolutionized the way we exchange idea and information. During this pandemic condition, we must thank internet, on account of which we could stay connected with our students, took online classes, and held examinations. There is a pretty long list of benefits which science has rendered to humanity. The same way, using the applications of science, we have developed sophisticated weapons of modern warfare, which are nothing but killing agents. Our world has witnessed devastating and catastrophic consequences of two world wars. Recent war fought between Armenia and Azerbaijan, destructive usage of scientific applications have annihilating power, and they force humanity to reel. Science as science is a dispassionate study. It depends on us users, what way we use these applications. Mahatma Gandhi once said, science without humanity is a sin. Science and technology, therefore, should have constructive, progressive connotation. Science is a way of life. Science is a perspective. Science is a process that takes us from confusion to understanding in a manner, well, that is precise, predictive, and reliable. Science and technology is not the panacea for the growth and security of the nation. Science does provide a platform of rationality, but this rationality should not be devoid of our emotions, intuitions, and most importantly, ethics and virtue. Thank you. Thank you very much.
Thank you, sir. Thank you very much for remind us the evolution of human being with science and its innovation on which we are unknowingly dependent. Thank you, sir. Dear participants, our chief guest for inaugural function is Honorable Dr. Brijesh Pare, sir, President ACT and Professor and Head, Department of Chemistry, Mother Science, PG College, Ujjain. It's indeed great honor to have you as a chief guest, sir. Friends, now let me introduce Dr. Brijesh Pare, sir, in very few words. Dr. Brijesh Pare, sir, has 33 years of experience in teaching of UG and PG as well. He has been awarded with postdoctoral fellowship from National Research Foundation in the year 1999 to 2000. He has 70 national and international research papers in his credit. He has guided 18 PhD students and 6 are actively working still. Ladies and gentlemen, now I invite Dr. Brijesh Pare, sir, to deliver his speech. Over to you, sir, please.
Thank you. Thank you. So I'm audible, and good morning to all of you. Yeah, it's really wonderful to be the part of this program, the International E-Conference on Recent Advances in Physical, Chemical, and Biological Sciences. All the dignitaries on the dais, Dr. Deshmukh, Dr. Naveen, Dr. Gandhare, and my very close friend, Dr. Gurunale, Professor Swaminathan is also there. So really the title of this E-Conference is very, very relevant because we are into the age of interdisciplinary research. And now to talk about the physical and chemical and biological sciences from different angles, we're definitely going to aid something very new. The conferences are always, they provide a potential opportunity for the deep interaction among the stakeholders. I mean, here, the chemists and the chemical professionals, the person from academia and from industry. So it's a very good platform, always a podium kind of thing. I wish this conference will explore the latest approaches and techniques in the field of physical science, chemical science, and biological sciences, and some kind of churning will take place and we'll get some very good outcome. So I'm looking to the title and the theme of the conference. I'm sure the event will provide a very good interdisciplinary international forum for the researchers and particularly the young researchers from India and from abroad. And I'm so happy, and I really congratulate the organizers of this conference, and particularly Professor Gurunale for having, just to make possible the registration from 24 countries and making the event a real international in terms of registration and participation. So, and I'm very hopeful that in the next 2 days, including the 2 days, there will be a lot of deliberations, and all the researchers will talk about their own field, their trains, what's the latest trend, what are their concerns, and what are the practical challenges they encounter, and what are the solutions they are coming out of that. So that will really serve the purpose of doing all these kind of things. And we are into the pandemic, and the e-conferences are really a way out to a great extent, very successful. Being the president of SCT, I take just 1 minute to let you all know about the Association of Chemistry Teachers. And our head office is Homi Bhabha Center, Science Education, Mumbai. This association was launched in the year 2000. So we are now into almost 20 years of age, and it's a group of more than 2,500 chemistry teachers from colleges and universities and from industry. And since the inception of SCT, we are working as a group for just to promote excellence in chemistry education, just by means of the curriculum development, just organizing many conferences and workshops. And SCT has been doing very regularly. You might be knowing about the chemistry Olympiad in the country. The stage 1, then stage 2, and then the stage 3. We are doing many such programs, like we are doing a concept test for undergraduate students. We are doing one research convention, and everything is going on very well. So, and I'm so happy to inform that it's really a matter of pride that the leading chemical scientists of the country, like the Bharat Ratna Professor C.N.R. Rao, Padma Vibhushan Professor M.M. Sharma, Padma Vibhushan Dr. Mashelkar, and Padma Shri Professor J.P. Mitta. They are the honorary members of SCT and the source of the constant source of inspiration and guidance. So I take this opportunity to congratulate once again the organizers for having invited such a wonderful, the battery of resource persons. I've seen Professor Swaminathan is there. And so once again, I congratulate organizers and wish that this program is going to be a great success. Thank you very much.
Thank you very much, sir, for sharing your thought-provoking words. And now I want to congratulate the honorary members on the behalf of the organizing committee. Thank you, sir. It's a great privilege to invite Honorable Dr. Rajuji Deshmukh, sir, for his valuable presidential address. Over to you, sir.
Hello? Can you listen to me?
You are audible, sir. Yeah, you are audible, sir.
Okay. Good morning. I'm Dr. Raju Deshmukh. I'm an orthopedic surgeon from Nagpur, and I am a friend of I'm thankful to you for calling me to inaugurate this seminar. It is a great privilege, honor, and a sense of happiness I have that a small place like Katol is holding a seminar on recent advances in physical, chemical, and biological sciences. Even before 3 years, possibly it was not possible to hold a seminar like this from a small place, and to get an international audience for this sort of seminar was nearly impossible. I think this is one of the things which has shown what science can do for us and for the humanity. Science is a gift given by God to us. But what do you do with science? We destroy the environment, we cause damage to the weather. Today only I saw that there is an unprecedented heat wave in America. Scientists, you all are responsible to everyone, every human being in the world. In sub-Saharan desert, people don't get to eat. Other places, they destroy food. Just imagine, maybe 20, 25 years ago, when there was no green revolution, people were dying because of starvation in our country. Science has given us great help, and it is a boon. I, being an orthopedic surgeon, I know what are the advances in joint replacements, this and that. The joints are fixed in the bone by chemical. There, the biology, chemistry, and physics, everything gets together and makes this joint replacement a success. I cannot tell you anything in this world which is not attached to all these three things. Yesterday only somebody was telling me that if you collect all the coronaviruses of the world, maybe they will be collected in a big spoon. Just imagine, such a small thing can destroy mankind. So the power of chemistry, biology is so big that we have to take help of it. The same virus which destroyed can be made to help the mankind also. All these things, you people, you are the stalwarts in chemistry and biology and other subjects. I request you to look at these things. See that atom bomb which destroys can also give energy. So, do the investigation, do the research in the things which can help mankind and maybe the universe, if there are alliances somewhere else. I think Nabira Mahavidyalaya is very thankful to you for giving a helping hand in running this seminar. I myself am immensely thankful to all the participants and members and people who have participated by way of internet in this conference. I thank you and wish you all the best. Thank you.
Thank you, sir. Your words are always influential and thought-provoking to all of us in Nabira Mahavidyalaya Katol. Thank you very much. Ladies and gentlemen, we are ending inaugural function of two-day International E-Conference on recent advances in chemical, physical, and biological sciences. I invite Dr. Nilesh Jadhav, Assistant Professor, Department of Chemistry, Nabira Mahavidyalaya Katol, to propose a vote of thanks. Over to you, sir.
No, I am audible, madam?
Yeah, you are audible, sir.
Okay. Good morning, all of you. It's my privilege to propose a vote of thanks on this occasion. I, Nilesh Jadhav, on behalf of the Department of Chemistry, extend a very heartily vote of thanks to the honorable delegates who blessed us with their presence and gave us their valuable time. First and foremost, I would like to extend a special thanks to Honorable Dr. Rajuji Deshmukh, Sir, President, Shikshan Prasarak Mandal Katol, for inspiring us. Also, I would like to thank our chief guest, Professor Brijesh Pare, Sir, President, Association of Chemistry Teachers, and Head of Chemistry, Madhav Science PG College, for gracing this occasion. Sir, you are truly an inspirational personality for all of us. Thank you, sir. Also, I wish to express my gratitude to our respected principal, Dr. S.K. Naveen, sir, for providing encouragement and support. I thank you, our beloved head of the department, Dr. A.D. Borkar, sir, Dr. W.B. Gurnule, sir, Dr. N.V. Bandare, sir, the convener of this event, for their moral support and guidance. Now, I declare that the inaugural session is over. Thank you. Over to Dr. Reena, madam. Madam?
हाँ सर. हाँ, yes sir.
Madam, hello.
Thank you sir. Hello. जी sir बोलिए.
Okay, continue.
Thank you Nilesh Jadhav sir.
Thank you, sir.
With this we are coming close to the inaugural session, and with a few seconds or minutes we will start the technical session. With the due permission of the organizing committee, can I start the technical session?
1 minute. Whether Ramaswamy, hello Ramaswamy sir.
So can we take a break of 5 minutes?
Yes, very good morning to everyone. Thank you very much.
Hello sir.
Yes, good morning everyone.
Yes. We can start, sir. Madam, we can start.
Wait a minute,
Professor
sir.
Sai joined.
But,
Good morning, sir.
I'm starting technical session.
Reena ma'am, just a second, please. Sorry to interrupt.
Okay.
Gurnule sir.
Yeah.
Actually, the link I had sent to you, that was a personalized link for you. Somehow by mistake, it must have sent to other panelists by you. So everybody who is joining with the link, you have forwarded from the email that is showing Dr. W.B. Gurnule only. So I request all dignitaries. So now I request all the panelists who have joined or all the guests, please rename yourself. There is a facility to rename. So once we rename our all panelists, we will start technical session. Or Gurnule sir, you can tell me, I can help renaming. Ramaswamy sir has renamed himself.
Adil sir, rename the Professor Ramaswamy. It's okay now.
He is okay
name
now.
Is there. Yes,
His
yes,
name
okay.
is okay now. Okay.
Another Professor Kiran Surati.
I request all the panelists to please rename themselves. Reena ma'am, meanwhile, you can please go ahead. Gurnule sir, is it okay to go ahead?
Yes, sir.
Okay. Can we start, sir? Yeah,
yes,
definitely.
Yes. Yeah.
Welcome you all again in the day 1 technical session, in which we are having with us Professor Punnadurai Ramasamy, Department of Chemistry, Faculty of Science, University of Mauritius, Republic of Mauritius. Sir is going to deliver a talk on the topic Computational Chemistry and its application in pharmacy and drug development. Now I request Dr. Trupti Khedkar, Assistant Professor, Department of Zoology, Navira Mahavidyalaya Katol, to introduce our first speaker for the day. Over to you, ma'am.
Hello.
Yeah, you are audible.
Good morning. Good morning, one and all. I have been assigned with an uphill task of introducing 2 personalities. Both these distinguished personalities have acquired a huge stature in the field of science and academics. And it may not be possible for me to elaborate all their achievements in short period of time. However, with utmost pleasure, I will try my level best to introduce them one by one. I firstly would like to introduce our esteemed speaker for the session, Professor Punnadurai Ramaswamy of Mauritius University. Professor Ramaswamy studied at Delhi University to get his doctorate in physical chemistry, and since then he has been involved in the field of teaching and research. He has wide spectrum of experience in the field of physical chemistry, particularly in the computational chemistry, and has been invited as a visiting professor to University of Johannesburg, University of South Africa, and King South University. He has supervised several MPhil and PhD students. He has participated in several international conferences and has 237 research papers to his credit. He has also authored 7 books and has worked on various funded projects. Professor Ramaswamy has been conferred with Best Mauritian Scientist Award in 2016. He is a member of various international organizations of repute. We are greatly honored to have Professor Ramaswamy with us to share his views on computational chemistry and its application in pharmacy and drug development. Please join me in welcoming Professor Ponnadarai Ramaswamy. Ramaswamy sir, over to you, please.
A very good morning to everyone. Thank you very much, Madam, for the introduction. And thank you very much, the organizing committee, for inviting me. It's my pleasure to join you for this international event. So I will start straight away my talk, and I think you will have to give me the host so that I can share.
Yes, sir. Just a second, please, sir.
Yeah. Yeah, it's okay. Now let me see if so is this okay to everyone? Does it work?
Yes, sir.
Yes. So if there is any problem at any time, please do not hesitate to stop me. Let me try and see the slide moves. It's okay?
Yes, sir. It is working properly, sir.
Okay. So if there is any problem at any time, please don't hesitate to stop me, right? So again, a very good morning to everyone. Like I said, it's my pleasure to join with you. And I can see that there are many participants from several countries, and I guess there must be some young scientists who are with us for this international event. So I'm myself, Ramaswamy, from the Department of Chemistry of the University of Mauritius. I am also a visiting professor with the University of Johannesburg and Professor Extraordinarius with the University of South Africa. I always like to give this slide whenever I give a talk at international level, because there is always a confusion, where is Mauritius? But I'm sure with participants from India, this is not a problem, but still, Mauritius is a very small island in the Indian Ocean with a size of about 1,200 kilometers square and a population of about 1.3 million. Of course, this cannot be compared with India, where the population is almost 1.3 billion, right? Now, before I really go to the scientific aspect of my talk, I would like to share with you a bit about Mauritius and then the University of Mauritius. Now, as you may be knowing, Mauritius is famous for the sand, the sea, right, and the sun. But you see now with the pandemic now, there are travel restrictions, and thus the tourism industry, it has really gone down. And but I hope that things will get back to normal and tourists will be able to come to Mauritius again. Now, this is one of the volcano. This is a crater. It's supposed to be a dead volcano, but some scientists saying that it's a dormant one. I really wish that it is a dead one, because if it is dormant, the day that it erupts, Mauritius will not be there due to this eruption. This is a mountain known as Le Monde Mountain, and it is officially recognized by UNESCO because it happens that you may be knowing that in the past, there were several slaves who were coming to Mauritius, and when they were trying to hide their masters, so they were hiding themselves in regions of the mountain, and they jumped to death when their masters came to look for them. So this is a brief about Mauritius, and now the University of Mauritius. Now, the University of Mauritius, as you may be knowing, so things really started in the 1950s. So things started in the 1950s with this building, which I'm showing down. It was basically meant for doing research in agriculture. As you may have realized that at that time, Mauritius was really dependent on sugarcane. But now with industrializations and things have evolved, now we have a full-fledged university with a student population of about 10,000 and a staff population about 1,000. We have different faculties ranging from pure science, management, medicine, and then engineering. Now, myself then, I'm here today for this international event to share with you a presentation, and I will be talking about computational chemistry and its applications in pharmacy and drug development. I will try to share few important points with you, and I hope that by the end of my talk, you will be able to really have a grasp of the subject and how, for example, computational chemistry can really be useful in these fields, particularly pharmacy and drug development. So in the next, let's say, 30 to 40 minutes, I'll be talking about computational chemistry, its development. I'll be talking about regression and docking, applications of computational chemistry in pharmacy and drug development. I will summarize. And of course, if you have questions, it will be my pleasure to address. So is everything okay? May I go ahead?
Yes, sir. Everything is okay. You can.
Very good. Thank you very much. Right. So let me start with what is chemistry. Right. And then but the idea is for me to explain clearly to you what is computational chemistry. Now, remember that chemistry is one of the scientific fields, and thus experiments are important. You cannot do science without experiments. You cannot do chemistry without experiments. It's unfortunate that, for example, I don't know about the situation in India, but it happens that there are things which are really changing across the world with respect to how chemistry and science, like they're being taught. I give you a very simple example, right? Now, we learn at the early of the secondary education level, starting with science, starting with chemistry, that hydrogen, the test for hydrogen, it burns with a pop sound. Yes, you know, it's very easy. A teacher writes, hydrogen is tested using a lighted splinter. It burns with a pop sound. Fine. But then I'm very sure that this is something that can be easily demonstrated, where you have hydrogen gas being produced, and then you insert the lighted splinter, right? It burns with a pop sound. You know, that the effect is much better, and it really gets into the mind of the student. And, you know, this sort of like practice, this sort of practical, some students really get interest in the subject, and they develop an interest to go into science. You can easily share a video on YouTube. I don't think this is worth. And personally, I don't see anything wrong for allowing the student themselves, of course, under supervision, to try to test for high oxygen gas, to test for hydrogen gas, and so on and so on. Right. So my point here is science is a subject that has to be taught by doing the experiments, same for chemistry. But then you'll realize that now there is a branch of chemistry which is computational chemistry, and this can be useful. But the question is now, what is computational chemistry? Allow me to give you a background. I'm sure that all of you may be knowing about physical chemistry. I'm sure that you may be knowing about organic chemistry. inorganic chemistry, environmental chemistry, analytical chemistry, and pharmaceutical chemistry, right? But then, what is computational? I will share a picture with you, and this is a picture which really makes students or others afraid of computational chemistry, right? So, and in that way, I will explain to you why the subject has progressed and some of its importance. Now, some people, you know, they confuse computational chemistry. Is it quantum chemistry? Is it mathematical chemistry? Is it theoretical chemistry? Yeah. But then, yes, I'm sorry, yes. Yes, may I go ahead? May I go ahead? Yes?
Yes,
Fine?
yes, sir.
Yes, sir. You can go ahead.
Okay, thank you. Right. So, computational chemistry is a branch of chemistry that uses the principles of computer science in assisting to solve chemical problems. It's just a branch of chemistry, like I just gave example before. It's a part of chemistry that uses the principles of computer science in solving chemical problems. How? This is now the most important aspect. I'm sorry, my slide is not moving now. Something has happened. Let me see how to, oh, sorry. Yes, so I'm sorry now, I hope it's better. Yes, now, this is the equation that I was saying, the figure that I wanted to share with you, that really makes students and others afraid of the subject. You may have guessed this equation is your famous Schrodinger equation. But why is it of the fundamental importance in quantum chemistry? How it is related to computational chemistry and so on. Now, let's go back. Let's go back. Okay. For those of you who have a basic knowledge of quantum chemistry, I hope that you know that the Schrodinger equation is the equation which can be solved exactly only for one electron system. I'm referring here to the hydrogen atom. But you may realize that chemical systems are not those limited to hydrogen atom. It is impossible for you to solve the Schrodinger equation for a system where you have more than one electron. But then what do? You cannot obtain an exact solution, but that does not prevent you from obtaining an approximate solution. So how do you get the approximate solution? There are different approximate methods which can be used. I can just mention, for example, the Hartree-Fock method, the MP2 method, the density functional theory methods, and so on and so on. So these are methods that basically try to solve the Schrodinger equation numerically, trying to get an approximate solution. And this sort of iteration to achieve an approximate solution can be fastened using a computer. Therefore, if you use a computer, apply the approximate methods to solve the Schrodinger equation numerically, you are using computational chemistry. And now, for those who really understand the subject, I'm referring to ab initio method. Ab initio method, you are not dependent on any experimental parameter. You're only concerned with the system. You really get whatever you might be interested. For example, the structural parameters, the energetic parameters, and so on and so on. I will be giving you some examples. Now, why it has progressed? So you may have guessed that it has progressed because now you have an explosive growth in the computational power. You have user-friendly software, and you have faster numerical methods. but I want to put a stress on the availability of user-friendly software. You have to be careful. It's not that because you have friendly available software that you just do a computation in the black box. Sorry. You do a computation without understanding. You may end up with results, but then you'll find that the results are really not having any meaning. So a basic concept of the subject is very important. That's why, for example, in my university, in the way that I have been working, students, they have a specific module on computational chemistry in their undergraduate, even at their postgraduate, and then they use the methods for the projects. And of course, they use the methods if they go for NEP PhD. You know, there is nothing wrong. There is nothing wrong with the whole development of computational chemistry. I will take you back in history and really try to make you part of the explosion. Now, I referred to a quote from Gay-Lussac in 1808, and you realize we are almost what? 210 years back, maybe more, huh? Right. Now, we are perhaps not far removed from the time when we shall be able to submit the bulk of chemical phenomena to calculation. So this was predicted by Gay-Lussac that we are not far from this sort of calculation. But then in 1929, I quote from Dirac, the underlying physical laws necessary for the mathematical theory of large parts of physics and the whole of chemistry are thus completely known, and the difficulty is that the exact application of these laws leads equation much complicated to be solvable. So the whole theory, no, but then you end up with equations which are difficult to solve to obtain the exact solution, but then methods have been used to obtain approximate solutions. And this has been the whole development of computational chemistry. And now I quote from 1998 from Sir John Popple, the Nobel Prize winner. We celebrate the fact that mathematics has invaded chemistry, that by means of theoretical calculations, we can predict a large variety of chemical phenomena. So I hope that you can really appreciate the whole development of the subject, starting what people were thinking, what were the limitations, and now what have been the achievements. And of course, you might be knowing the subject has kept on raising interest. And in 2013, the Nobel Prize was again awarded to the field of computational chemistry to 3 brilliant scientists. Now, some importance of computational chemistry. You'll find that it supports the experimental findings, precede experimental investigations, explore systems under difficult conditions, prediction for novel compounds, and computational chemistry. It really helped in elucidating the structure of carbene, CH2, despite this being a very simple molecule. And of course, you really satisfy the criteria of green chemistry, except that maybe you're having all sorts of hardware that you have to be able to dispose properly. So with this then, I have covered about the subject, computational chemistry. I hope that now those of you who were not knowing, or they were just having a simple idea of the subject, now you can be having a better understanding of computational chemistry. Now, I will share with you how computational chemistry methods can be used in your research, can be used in your projects, and I hope that these will be really helpful. Now, let me start with novel molecules. Now, I'll give you an example, despite that this might not be straight away related to drug. Now, you have this famous molecule where you have all carbon system joined to the nitrile group. Now, this is trimethylcyanide. Now, this molecule was studied in the 1950s, and there was an idea of substituting the carbon by silicon. This idea was justified in the sense that carbon to be replaced by silicon, this compound then became a versatile reagent for introducing the cyano group into the organic molecule. In 1974, there was an idea to replace the carbon by germanium. And in 1990, the synthetic application was recognized. So 1950s, right? Then 1974, and then 1990. Substituting the central carbon by silicon and then germanium. So we thought, then, why not substituting all the carbon by silicon? Why not substituting all the carbon by germanium? So these become like novel molecules. You can use computational chemistry to get an idea about the structural and molecular and spectroscopic parameters, which ultimately you can be used. These can be used when these compounds are synthesized and characterized, right? So this is what we did, and ultimately, so we use the quantum mechanical methods to study the structure and spectroscopic of the novel triacylyl cyanide and trigermyl cyanide in the gas phase. Along a similar line, right? So we did a theoretical study, right, to look at the structural parameters and the change in spectroscopic parameters of a compound which you may have heard about, sulfur mustard. So for those who are really into the field, you might be knowing that sulfur mustard is a chemical warfare agent. People use it in a bad way for mass destruction. And now you have means and ways where you have detectors which can be used to detect sulfur mustard in very low amount. And of course, you have means and ways to destroy the sulfur mustard. But then what happens is that sulfur mustard forms complexes with moisture, with water present into the air. And these complexes, they behave differently with the detectors. They may go undetected. Therefore, you have to be very careful in having suitable detectors for suitable detection of sulfur mustard under moist conditions. So we looked at the structural and spectroscopic parameters of sulfur mustard when it forms hydrates with water, right? So if you want really, of course, to have additional information, you can check the paper, or you can even write to me. We can discuss further. Along the same line, you might be knowing about the A234 Novichok agent, which was used as the chemical warfare agent in the Skripal poisoning. If you go back to literature, maybe at that time, the literature was very poor with respect to this Novichok agent. But then we use the computational chemistry method to provide additional insights into its structure, molecular reactivity, and spectroscopic parameters of the A234. So these are papers which have already been published, where we've used the computational chemistry methods in trying to undertake our research. But then now we come to a very important aspect. Whatever I've talked before, maybe these are ab initio methods, where you are independent of any experimental data. But then you do have other methods which can also be useful. You must have heard about docking. You must have heard about molecular dynamics. You must have heard about some regression methods. But then here, I'd like to share some tools with you where you can do a sort of regression, but remember that these are not really pure ab initio methods, where now in these tools, you are really dependent on experimental data. With known experimental data, you really build a model, mathematical modeling, and then you use the mathematical modeling equation for your prediction. This might be particularly useful for those in the pharmaceutical industry, but again, you have to be very careful. Allow me to start with the Swiss ADME. Very simple. Your first step is you have to generate the smileys of the molecule, which is the simplified molecular input line entry system. You feed the smileys and then you get your result. I did it for a very simple molecule, which is acrolein, right? So if you start with acrolein, you can get the smileys online, for example, uses this link. And once you have the smileys, you can go to the Swiss ADME, where you have the link down. If you have your smileys here, and then you run the modeling, you end up with all sort of prediction for the molecule. For example, you end up with the log partition coefficient, you'll end up with the solubility, you end up with all sort of pharmacokinetics parameters, you end up with the drug likeliness and medicinal chemistry parameters. So this is very useful. But then, as I said, you have to be very careful with what you're doing. Now, I tell you, for example, you may be asking how valid, how accurate the results are. Very good question. Allow me then to go back to, for example, one of the experimental parameters. Let us suppose that you're really interested to get the partition coefficient of a compound. You all know very well. How do you get the partition coefficient? Very simple. You go, you distribute the compound between water and ethanol. You have means and ways to detect the water, the compound into the two layers. You take the ratio. You repeat it several times, you get an average, and so on and so on, and therefore you get the partition coefficient. That's fine. But I hope, as a scientist, you know that even what you have obtained experimentally is not 100% accurate, and there is an error associated with it. Similarly, when you're doing something using the Swiss ADME software, you are predicting fine, you're estimating, fine, but don't expect this to be 100% accurate. Why do you expect this to be 100% accurate? It has an error margin. And if this error margin is up to your satisfaction in your research, very good. If it is not, unfortunately, this tool is not good enough. Same thing for the solubility, and so on and so on. Right. But for now, I'll give you now something that I reviewed a paper 2 days back. I reviewed a paper 2 days back, and the authors, right, they've used the Swiss ADME, but they did not just use it for a organic molecule like you have here, but for some copper, zinc, and chromium complexes. But you know, I have a very important question here. I hope that you know that this method is based on regression. Most of the molecules which were used for the validation, they are organic. How can you use an inorganic complex for an organic database and try to get information? So this gives you clearly an idea that, unfortunately, I'm not blaming the authors. Please don't misunderstand me. I'm not blaming them. What I'm trying to say, yes, you have this facility. You can use it, but you have to be sure that you use it in the proper way. No one is taking any responsibility for any mistake that you're doing. So this is about your Swiss ADME. The next one is the virtual computational laboratory, where again you have the link. Again, you have to give your smileys and you get your results in terms of the partition coefficient and the solubility. And you see, this is very useful. You have a novel compounds and novel organic compounds before really going to your experimental procedure. You're interested to know about its partition coefficient, its solubility. So within seconds, you can really get down to your results with a margin of error, which you should understand. Now you have another one, which is the mole inspiration. Again, you can enter your smileys, and you can calculate various parameters, predict various bioactivity, and the other generators you can check online and see whether really these tools are useful to you. For example, I did it with acrolein. You end up with some parameters, right? And you can have the partition coefficient, the surface area, and so on and so on. So you have to see whether each of these parameters may be useful to your research. The last one is really interesting again. You go for the toxicity prediction of a molecule. Can you imagine that before whether a compound was toxic, you have to go to all sorts of experiments, all sorts of in vivo and in vitro studies, right? You have to be careful. I'm not saying that you should not do, but you can have prior information before you really go into the scientific part. Now, this is a tool that you can use online for predicting the toxicity of chemicals, right? So again, you have to give the smileys and then decide about the different sorts of toxicities that you are really interested to predict, right? And once you do it, you'll get all sorts of results, and it gives you an error margin in terms of the probability that the results might be like reliable. So I've shared with you 4 of them. There are many others, right? Now, you may be asking, you may ask me a question whether these are free or to be paid. So these are free, but then does not mean that when it is free, it is not good. It also doesn't mean that because you pay for another tool, that tool should be better. You should see for your research what type of accuracy you need, what types of error margin is to your satisfaction, and then you can use the tool safely. The other one is, like I mentioned, molecular docking, right? Where you really look at the interaction between species. You have your target, you have your drug, you have several drugs. You can use docking to decide which of these drugs will interact better with the target. That gives you an ultimate idea about which drug might be more suitable. But I'm not saying that if you have done this calculation for 1 day, for 1 month, I'm saying that this drug should go on the market and be used to treat any particular disease or any particular disorder. Never. You should go through the procedure. Remember that drug development itself takes years, and unfortunately it has to be. This is a tool that can be used for you to enhance your research, to give you additional information. So this is one paper where we've used the molecular docking to study the derivatives of favipiravir as potential drugs for the Ebola virus. I'll not go into the detail, but if you have time, you're interested, you can go specifically to the paper. And so this is the latest paper that we've just published, where we've looked at the theoretical study of the interaction between peptide tyrosine PYY, a newly identified modulator in the type 2 diabetes with the receptors. We've looked at interaction with 2 receptors, right? So, and we've used a combination of docking and molecular dynamics in this research. I'm not going to expand because I'm not sure the participants will really benefit from that. But if you need to have any like focus lecture, it will be my pleasure upon invitation to give. But this one I'm trying to give a broad idea about the possibilities that are there in computational chemistry methods which you can use. Ultimately, all these you can use in drug development. So you may be knowing that computational chemistry can be used for studying several molecules and their reactions, particularly novel compounds. Now, I give you a very simple one. We all know very well that sulfur compounds, they have been used as drugs, but then selenium was regarded as the toxic element until later they realized that selenium compounds can be used as drugs. Similarly, the tellurium compounds, they face the prejudice, but it can be used to treat several diseases. And you might be knowing that there is a need to have new drugs because of drug resistance and so on, right? So we've done some studies with respect to the tellurium compound, with the idea that there might be new diseases become more resistant, drugs have to be more effective, the cost should be down, and so on and so on, right? So we've started with the prediction of the structural parameters, the spectroscopic parameters, the molecular parameters, and rate constant with respect to interaction with the target. Now, we've studied the tellurium analog of uracil and fluorouracil, because you might be knowing that these are the components of the biological molecule. All right. So, like I said, we've looked at the structural, molecular, and spectroscopic parameters. I'll not go into the scientific details because these might not be relevant for this talk. But like I said, I can give more focused presentation. And we've also looked at the fluoroanalog, right? So, and of course, we know very well that there are limitations with this, right? So, but there is a possibility for exploitation. There are other aspects that we need to look at, right? But then this gives an opportunities for the experimentalists to have prior knowledge of the compound before really going for further exploitation. We published this paper in Computational Biology and Chemistry, where we've looked at the 2,4-diethyl-uracil and its 5-fluoroderivative. So if you want, you can really go into this subject and look at. Now, recently, we've studied the anti-Ebola drugs, right? Where we've used the computational drug repositioning case study, right? And this paper was published in the RSA Advances. And our latest, one of the latest papers that we have, so in the COVID-19 pandemic situation, you might be knowing that favipiravir and remdesivir, they are commonly used as drugs. What about using combined drugs, right? So using combined drugs for and check whether they can work better against the virus. So this is the paper. And we have also published some papers using the computational chemistry methods about the triiodide compounds. Again, you can check. And this paper really catch attention with respect to the viewers. And this one, where we've checked about the natural product, ipaforin, right, in its action in terms of the structural and biological properties. The last one, which I just mentioned, is something which is really important with respect to the natural product chemistry. So with this, then, I hope that I have been able to use the time allocated to me. I have given to you an idea about chemistry remains experimental science, but computational chemistry can be useful. Computational chemistry, I've explained, regression and docking. I've explained about the applications, and I'll be very much happy to have collaborations with people, particularly in the field of experimental research, where we can apply computational chemistry. And I've mentioned also about several limitations, which you have to be really careful with what you are doing. Now, I can't just give a talk without the acknowledgement. I'd like to thank the organizers and participants of the International E-Conference on Research Advances in Chemical, Physical, and Biological Sciences, Professor Gu Nule, for inviting me, the Computational Chemistry Group at the University of Mauritius, and all collaborators. I'm pleased to note that there are several participants joining us today, and we will also have an international conference and online, which I will share the link in the chat system. And if you're interested to submit an abstract, let me know, because we are really short with respect to the deadline. So far, we have already received about 200 abstracts from almost 50 countries, and you will have the chance to interact with almost 4 Nobel laureates. So with these now, I'd like to thank you very much again. And if you have questions, it will be my pleasure to address. Thank you very much.
Thank you very much, sir. Thank you once again for sharing your deep knowledge about computational chemistry and its application in pharmacy and drug development with us. Your session was full of enthusiasm and valuable knowledge, sir. Thank you very much once again. While moving ahead in today's technical session, the next distinguished to honor us with his virtual presence is Dr. Kiran Kumar R. Surati, sir. Gurnula, sir, can we proceed for the question answer session? Can we? Do we have some questions? So, or if we do not have, then we can move ahead.
And there are a few questions in chat box.
Okay.
There are few questions in chat box. If sir can take those questions.
Yeah, sir can take those questions.
Okay, so yes, so I can see that I can see one question. What is the difference in time between computational and chemistry in lab? Well, it all depends, like I'm saying, man. But you have to be now. Of course, experiment may take longer time. But even computational chemistry method, if you really want to achieve the best accuracy that you want, that can also be taking time. But for sure, computational chemistry, you can take less time to have prior knowledge before you really start your computational work. Right? Now, again, I come to a question, how exactly is computational chemistry with experimental findings? This is a misleading thing in the sense that you are assuming that the experimental findings are exactly correct or perfectly fine. There might be errors associated with these experimental findings, and you're trying to modulate your computational chemistry to achieve these mistakes. So you have to be very careful, right? Okay, so I hope. So can you tell some software about computational chemistry? Yes, so basically we use Gaussian, but there are several software. It depends on which system you have. For example, we use OCA, we use the Quantum Espresso for solid system. It really depends on the system that you are studying. Now, what precaution we have to tellurium? Well, I'm not too sure I can answer with respect to the experimental part of tellurium compound, but I can assure you that is computational chemistry much evolved in real-time application? Yes, of course, you have some tools that can really give you instantaneous results, and you can have. It all depends on the system that you're studying, right? So I hope that these are really useful to you. If you have a specific question, you can send email to me and we can discuss. I look forward to collaboration. And if you want to have focused presentation with respect to specific topic, it will be my pleasure to address. And I invite you to visit the website of the conference. And if you want to submit an abstract, please be fast. Thank you very much.
Thank you, sir. Now we have with us Dr. Kiran Kumar R. Surati, Associate Professor, Department of Chemistry, SP University, Anand, Gujarat. And he is going to share his expertise on the topic Advances in Photocatalysis. Now I request Dr. Trupti Khedkar ma'am to introduce our second speaker of the day, Dr. Kiran Kumar R. Surati, sir. Over to you, ma'am.
An afternoon of chemistry. It's my pleasure introducing our most revered speaker, Dr. Kiran Kumar Surati. He has an experience of 13 years in teaching and research. Dr. Surati is a life member of many national and international professional organizations. He has been granted Indian patent for his research on heteroleptic IR3 complexes for photoelectrical applications. He has completed 6 funded projects and 2 projects are still ongoing. To add to above achievements, he has also presented papers in various national and international conferences. He has 30 research papers and 1 book to his credit. Ladies and gentlemen, please join me in welcoming Dr. Kiran Kumar Surati. Dr. Surati will enlighten us with his views on greener luminescence-based molecule for optoelectrical applications to overcome e-waste problems. Surati sir, please.
Thank you, Trupti madam, for the nice word. I also thank to Gornule sir and his team for organizing such a nice event, that is the e-conference. During this time, this conferences is really help as Professor Ramaswamy telling us in the previous talk. So I think my voice is clear to all.
Yes, sir. It is clear, sir.
Okay, thank you very much. So today I will going to discuss two area of my research. That is, one is about the optoelectrical applications with some zinc and metal complexes for light luminescence based LED, that is known as organic light emitting diodes, as well as one of the IUPAC project with the Professor Dine from the Middlesex University, UK, which is on e-waste management. So here I clubbed two projects and prepared my talk to encourage many researchers in the our area or in the area of this e-waste and develop some sustainable material which is known as a greener luminescence material. So here I would like to start with my discussion, just to share my screen to all. So I hope my screen is shared with all. Is it okay?
Yes, sir. Yes, sir.
Okay,
it is.
Yes, so I just maximize it. Okay. So this is the topic of our discussion in this event, that is a greener luminescence based molecule for optoelectrical applications to overcome the e-waste problem. So this is about the that is known as electronic waste and the optoelectrical applications or optoelectrical equipments which we are aware with. So by replacing this with the greener luminescence based molecule. So this is affiliation of my institute, that is Vallabh Vidyanagar Anand, which is also known as a Milk City. So the overview of my talk. So first we discuss something about the background, how this e-waste, or what is the e-waste, and what are the importance of that e-waste, how they are connected with many area and many problems when the all over the world is thinking about the e-waste. So this is about the background. Then what are the challenges which is we are going to discuss, that is challenges of e-waste, which is mainly tell us about the how they are going to, I can say, require for the to sustain the earth, to sustain the globe. Then what is the hazardous elements and chemical use for this device? I think I have to just stop the camera, so maybe the data problem can be. Just a minute. Okay. So the strategy to manage this e-waste, how this e-waste can be managed, that can helpful to overcome this problem. And finally, after this strategy, what we are discussing, how this alternative organic semiconductors which are useful to control or to manage this e-waste. So that we are going to discuss something about our research in this one of the ongoing project, that is a scheme for young scientists and technologists. So that we are going to discuss in this topic, and future perspective of organic semiconductors and e-waste management. So these are the overview of my talk. So let's start with the e-waste. So maybe, as you know, this is the you can say very simple word for this electronic waste. That is the electronic waste that is defined as a comprise the waste that is electronics and electrical goods that are not fit for their original intended use or have reached their end of life. So this is the we can say the definition of e-waste. So these are the picture which is showing the most probably the cell phone, then other e-waste garbage which is dumped at one side. This is about the display or computers and other electronics equipments. These are the monitors, TV and other stuff. So these are the other computer, laptops and other things are, this is the internal parts of that particular e-waste. So see, these are all about the considered as e-waste when their lifespan is over and we are dumped somehow somewhere in the open space, that is some of the site which is contaminated with this waste. So this e-waste is a big challenge worldwide, definitely, and that is why the IUPAC is interested to control and to aware the people for this e-waste and their management. So basically, the country like India, we are not exactly the origin of this development of e-waste. As far as today, people are from the other country which are generate more e-waste as compared with the India. I will showing the data. So according to that data, I will like to share you this thing that many of the country or you can say the developed country like UK, USA, Canada, they people are having more e-waste generation, and we people are the country like India. It's like a developing country like India, Nigeria, and others, China, definitely. So people are just arrange or recycle this e-waste or manage this e-waste and recover this e-waste. So we people are the people who is just collect this e-waste and finally extract the metal and other stuff. So this thing are very harmful to environment as well as the human also. So these are the main disadvantage of this e-waste. So how we can control, how we can manage this waste? There are few strategies which is you can say explained by the many of the scientists in the worldwide by various scientists. But here I would like to tell you something different thing for controlling this e-waste. So further, how this e-waste is generated from the various electronic equipment. So this global e-waste monitor, it has classified by the desired electrical and electronic equipment divided into the following categories. So the mainly there are 6 categories which are categorized the various kind of electronic equipment. This one is most eye-scratching one, that is about the screen, monitor, television, then about the laptop, definitely cell phone. This all are within this category. Here also there is a small IT equipment like telecommunication equipment, mobile phone, tablets, etc. So this category, this is about the screen of monitor, television, laptop, and this one. These two things are the greater area where the e-waste is generated. In this IT industry and about the display where the laptop is mainly concerned, these two technologies are run parallel, and finally people are someone is raised his hand. Any query is there? Ma'am, my voice is clear?
Yes, sir, you are very clear.
Okay, then okay, no problem. So this thing is about the to this area where the IT industry, or you can say telecommunication industry and the display industry, both the things are run parallel. And this as this technology is moving from the 1G to 4G, and now we are talking about the 5G. This e-waste generation for this mobile phone and other stuff is enhance, or you can say accelerate in the very huge way, and people are replacing their monitors, their computers and their cell phone like anything. So this is about the main source of generation of this e-waste. Apart from that, there is a temperature exchange equipment like a cooler, some refrigerator equipment, so ACs that are under this category. Then about the lighting device, the fluorescent lamp, LED lamp, and etc., which is in this category. And then large equipment, that is about the washing machine, dishwasher, and etc., which is in this place. The small equipment about the vacuum cleaner, microwave oven, and other stuff is in this side. Apart from that, there are many other things which is dumped under the banner of e-waste, or under the electronic equipment like the rechargeable, or you can say some chargers, some wires, some batteries. These all are generate a lots of e-waste and hazards. So mainly when people are monitoring, or you can say collecting what type of e-waste is come out with this all gadget. There are metals, definitely there is a semiconductor metals which are placed under such equipments. They are under this category. Apart from that, some other molecules, that is about the organic molecule, volatile gases, harmful reagents, that is also showing this harmful effect. Apart from that, the macromolecules, polymer, oligomer, and plastics, they are also generate during this recycle or reuse process. So this is about the hazardous chemical effect of this e-waste. So what type of the metal, as we discussed, this is a very important part of the any semiconductor or any semiconductor gadget. So this is antimony, bismuth, and definitely cadmium, chromium, cobalt, gallium. Further, this gallium is not alone, the gallium arsenide and other stuff. So then germanium, molybdenum, nickel, selenium, silver, lead, tin, iron, yttrium, and zinc. So these metals are generally used for this gadget. Apart from that, there are other metal are also used, which are very costly and very precious metal, that is iridium, gold, platinum. They are also within this equipment. Silicon is there. So why I am not placing in this, these are the precious metal. Definitely they are also recycle and they are less harmful effect as compared with this metal. So definitely the gold, platinum, and the iridium, they are also having the lesser effect. If we concern about the hazard, they having low hazardous effect. So these are the data which is appeared in this paper, that is about the science of total environment. So this is published in 2009, and this data is I'm collecting from there. Definitely after there few revisions are there, but that revisions having some you can say some problem or some controversy, and that is why I am showing this data. So in 2009, it is maybe 10-year back data. So the current data is also having these proportionate, and the country like this Germany, UK, Switzerland, China, and then India, they people are having the different you can say ton of this e-waste generation. So if you see, this one is having the higher e-waste generation per year in the 2007. In the similar way, the country like China is also having the same thing. Germany is also having this same thing. If we look towards the India, we having the lesser digit, and even China, there is a huge market of this thing. So though here I would like to tell you something about the country like Korea, which is and even Japan. They are the main origin of this semiconductor industry. They are the first who has running with all this development of this semiconductor industries, but they are managing their e-waste in the proper way, and that is why the e-waste generation and e-waste data of that country are less as compared with the other country, and that is why the name is not mentioned over here. Definitely they having some strategy, some management strategy to manage this thing. Definitely that is also not disclosed in any you can say public domain. So this is about the major category as we are discussing this thing. So this is about the larger equipment, smaller equipment, IT equipment. So how this e-waste can be managed? So strategy to manage this e-waste. So first one is about the assessment of this life cycle. So this is life cycle assessment. How any gadget can be useful for how long, or what are the time duration. If we consider the cell phone, mobile phone, the duration is hardly 2 years. After this 2 year, the technology is you can say change. So people are using the 2G mobile. Now this 2G mobile is not going to use full to make many things, like we are not going to e-conference, or we are unable to do connection like this thing. The similar way, the 3G 4G. So as this technology is or this IT technology is increased, or that enhance their facility, definitely these things is replaced. So sometime what happen, the life cycle of this gadget is not completed. This mobile can be used, this some washing machine can be used, but people are replacing them you can say before their the cycle. And definitely that is the one way where the life cycle assessment is important. So we have to use this equipment with their entire period, and then we can replace, or you can say we can buy some new things. So this is the one strategy where we are taking the thing with the proper use of that particular gadget. Either it may be a mobile phone, it may be laptop, it may be some other small equipment, big equipment in our household use. So this is the one way where we can manage this e-waste. The second one is about the material flow analysis. So how this material flow analysis, or what is the meaning of this material flow analysis? So if we can say if we have a using some mobile phone or some laptop, so what type of material it consisting, or what type of chip, what type of semiconductor material inside this particular gadget, that is also important. It having some harmful effect elements, if it having some huge circuit motherboards and other stuff, then it is really difficult to manage this material. So that is the one big issue. If we compare the same thing for like a bigger equipment like a washing machine, so the basically what happened, what are the internal part of that machine? That is nothing but the electrical motor, which is having the wire, and that is very really simple way to you can say recycle or use that particular metal wire from this motor. So this is the easy way where we can use this particular material. So this material flow is important thing. In the similar way, the third point is about the multi-criteria analysis. How this multi-criteria analysis is the useful to manage this e-waste, in which we are monitoring, or you can say analyzing the material inside that particular e-waste. that is assess how it can be recycled, that is assess as well as what are the energy used to recycle or reuse that particular metal, that is also analyzed in this multi-criteria analysis. So this one is a much important point when we manage this e-waste. So here I would like to tell you one thing. The e-waste is why the e-waste is a big problem, because to collect some from this e-waste, there we have to apply some energy, we have to use some process, and for that there are huge energy is required for to manage or reuse that particular elements or particular metals and extract particular metals. So in that way, this multi-criteria analysis is the important task. In the similar way, extended procedure on responsibility, definitely the important point where people are aware with what we are dumping, what we are not using and throw away in the open area, in the landscape. So that is about the extended producer and responsibility. So whatever the you can say industries and other stuff which is produce such type of thing, they must have to use that responsibility. Apart from that, the awareness is the one of the important way where we can manage this e-waste, because people are not aware why this e-waste is a big problem and how long it create the big problem that we people are not realizing today. So the challenges, so what are the challenges as in the e-waste management? That is about the above mentioned strategy are present, but still it require more time and energy to recycle or manage the e-waste. So these are the strategy which is we are adopting. And finally, by using this thing, we can manage somehow somewhat the e-waste problem. But the thing is that it requires some more energy, and the same way more energy requirement, that is about the recycle or reuse of such e-waste. This is a big problem. Sometimes what happen, I'm using certain thing, I'm recycle this e-waste, then we are minimizing these e-waste definitely, but whatever the energy we are utilizing for this e-waste, that is huge, and that is also a big concern. The another concern is about the hazardous effect of the human and the environment. So this is also a very important aspect where the hazardous effect of that particular material, that is a big concern. So when we are managing something, if we come out or if we remove some waste, further it create a big problem for the society. So this is about the also a big challenge to overcome this thing. So what is to overcome and to come out with all these limitations, some challenges, we set our objective. We set the thing that is replacing the old material with the new one. So what we are basically using the semiconductor material, organic stuff, the elements, some metals, what we are using conventionally, that is replaced by something new material. So here I promote many of our group to just think in this direction, because see, there are huge number of material. I have surveyed something and I have proposed something, but apart from that, there are huge number of material which are available, and they must be under the category of some unique material, new material. So this old material must be replaced by the new material. This new one material, that is new material, is nothing but the which is a sustainable material, which is having lesser effect on environment, human, etc. So this is about the thing. Then the thing is about the review of a smart alternative to conventional semiconductor device. So that is about the we have to find the alternative, this conventional device and conventional semiconductor material by the renewable, biodegradable and non-toxic organic semiconductor. So what we are replacing, the replacement is about the conventional material, which is having some hazardous elements, hazardous plastics and other stuff, which is replaced by the newer material, or you can say renewable material, some biodegradable material and non-toxic organic semiconductors. So here these are the alternative material which are used to overcome this limitation of e-waste. Then processing technology must be simple. Yes, definitely. When we are talking about the optoelectrical equipment, definitely the processing is very difficult. Here, when I say optoelectrical applications, it is definitely mainly concerned to the cell phones, to the laptops, to the display devices, to the lighting devices such as LED, OLED, and etc. So these things are mainly use the metal, which is process, and this process is also require a huge energy. So whatever the material we are propose here, that is further we propose as well as we review something that is having the lesser process or processing energy required for processing is very less as compared with the conventional material. So whatever the processing technology must be very simple. And I must add one point is whatever the technology for this processing must be energy efficient. So if the processing is requires some huge energy, so that is further a meaningless thing. So whatever the technology, that must be very simple, and the processing is very cost effective as well as energy efficient. So the another thing is about the cost effective and simple device fabrication technology. So we have to focus in that particular area, that is about the processing technology and about the cost effective and simple device processing technology. So after this all, we have to replace, we have to find the objective and we have to focus on that particular thing. So there are three main areas where we concern about the material replacement, then about the processing technology, and about the cost of that particular material. So whatever the material must be cheaper, as well as the processing is very simple to fabricate any optoelectrical device. So these are the alternative approaches of this e-waste management, that is electronic system consisting of a renewable and the biodegradable material, and minimal amount of the potential toxic materials are desirable. So whatever the material, that material must be having a biodegradability. So if we dump somewhere, it must be degrade at certain period. Within the certain period, it must be degraded. It also having the non-toxic effect. The toxic effect is not much serious as compared with the conventional one. Apart from that, there are natural and nature inspired material. Definitely nature tell us many things to make many things simple. So when we are using some natural material, then further they are useful to fabricate that such type of semiconductor. I will show you certain material which are very simple and available with nature, and we must have to focus on certain type of material to fabricate some this organic semiconductor devices. So the next point is about the work to identify semiconductors that are stable in their phase of challenging environmental condition, yet degradable at the end of their product lifetime. So whatever the material, that must be degradable, but definitely that material must be useful for a certain period of time. During their use, they may be not degrade. So that is a very important point. It must having certain lifetime. After this lifetime, maybe it degrade, then it is okay. Because like cell phone. So cell phone is people are using maybe more or less 2.5 years. After this 2.5 years, maybe the cell phone is damaged, or maybe people are replacing by buying some new advanced gadget as compared with the older one. So in that way, people are not using their full life cycle of that particular equipment. So whatever the material which we are proposing over here, that also having the certain life period. Suppose I can say 2 year or 3 year. So within this 3 year, that must be degrade, and you have to throw in that particular gadget, and it can be degrade. So this is the work what we are presenting over here, which is under the IUPAC technical report. This is Professor Diane Purchase, and she is working hard and leading this our group that is on e-waste management. So this project is sanctioned by the IUPAC, and this is the technical report of that particular topic, where we are concerning about the global occurrence, chemical properties, and ecological impact of e-waste. So this technical report is come up with the huge authors, and definitely here I am representing from our country, and how this e-waste can be controlled by the using them smart material, or you can say sustainable material, some natural kind of material that we are focusing on that particular thing. So this is about the report. You can, if you can join this group, tell me. We can join this. I will introduce in this particular group. So definitely how this material can be used, or what type of material can be used. So there is a renewable, biodegradable, and non-toxic material. So whatever the material, that material having this renewable, biodegradable, and non-toxic material. So people, there are 4 categories mainly, which are I have identified and summarized over here. That is about the paper, leather, silk, hard gelatin, and the biodegradable plastics as a substrate of electronic devices which is used. So this is about the thing. Just a minute. So the second material, which is about the smoothing agent, such as polymethyl siloxane and rosolic acid. These are the material which is smoothing the device, or it can be gelatin kind of material which is used. Then definitely some other material. This is a biomaterial, that is DNA and nucleobases, as example of exotic dielectrics with the low dielectric losses. So this is about the material, mainly about the come out with the animal fat and animal kind of stuff. So this is about the DNA kind of stuff, some bio kind of material. So this is the use because they having also dielectric property. Then the fourth one is about the natural and nature inspired and common commodities. The semiconductors are also under that particular area, which is used in the organic semiconductor. So these are the 4 category which are more concernly degradable, some of that renewable, and definitely non-toxic as compared with the conventional semiconductors. So these are the papers based materials which are published by in the advanced functional material by this author. So they promote the paper based material which is used for a cycle, and we can use a different fabricate the different gadget by using this process. So here see, they are using the different processes of this on this paper substrate. Basically this substrate is used in the semiconductor, that is mainly on the glass, and that glass is you can say coated by the indium tin oxide. So that type of material are used in the conventional one, and even the silicon based material are used, which are very costly, which are very expensive, and definitely when we recycle, we have to use this particular silicon which is coated on that particular substrate. It require more energy to extract that particular silicon or particular metal. Even the gallium arsenide and other semiconductor are also used, that is different p-type and n-type of material which are used. They are also suffering with the same problem. When we are going to extract from this chip, that is very difficult. That is using on the plastic, or sometimes which is used on the ITO, that is difficult to scratch and difficult to extract that particular metal from that substrate. So here this is about the substrate which can be replaced by this material. These are the photo which is showing about the organic field effect transistor. So this transistor, as we know, the transistor is the one of the important tool in the any electronic equipment. So definitely they here this paper based substrate and some of the leather based substrate which is used to fabricate the device of organic field effect transistor. So this is also a very useful technology where people are using such a substrate. Even their you can say recycle process is also very efficient. So I hope I have a time. So commercially available degradable polymers like Ecoflex, then BASF, so that is also nothing but the one of the, you can say, polymer which is mainly degradable with their time cycle. So at that type of biocompatible hard gelatin capsules and even edible caramelized sugar as a substrate in the organic field effect devices or transistor which is used. So that type of biodegradable polymers are used where it is named by different way. So that type of material is also used to fabricate the substrate for this field effect transistor. Some hard gelatin fabricated from this pork skin and even born with the various additions of a plasticizer and easy of production in the various form of their complete biodegradability. So definitely this animal fat, animal skin, which can be also used to fabricate such kind of devices. So definitely sometimes people are also having some problem with using certain thing, but definitely this is the right way to utilize such a you can say sustainable materials. Further, the example of exotic biodegradable substrate are the lactic acid, as we all are now. Apart from that, this is about the polyglycolic acid and the other collagens. They are used as a substrate in the many devices. So this is proven and that can be used for a device. Definitely there are some limitations, but now people must have to focus on such kind of material, such kind of thing, that to improve the quality of their life, or you can say quality of the material as well as quality of that particular gadget, that can be improved by research only. Okay, so we have to focus our concern about that type of material. That is the important aspect. So this is the see one of the example of luminescence based LED which is fabricated by this bio LED. So this is about the material which is generally, just a minute, this is about the different material and this is about the bio LED. So how it is compared with the inorganic material, that is that we are going to showing over here. This is about the bio LED, and this is about the LED, which is having some inorganic material. So these are the two pictorial representation of that particular thing. Here we can say it is 25, and this is about the even 20 watt. It can show the good illuminations. So this is the thing which is used. So replacement of the older material, conventional material, or the, we can say, the material which are having the limited source by the some biodegradable material, as well as naturally occurring material. That is the motive of our work. So some other natural material which is used, definitely, as maybe people are aware with, these are the natural material, like this is about the corn, or the raw material which is come out from this corn, and about the sugar cane, some about the vegetables and other stuff. Some is about even from the milk and other thing. Definitely there are few things, and even there are many things which are mainly focusing on the edibles, and the government is restricted somehow according to certain law of not using such a type of thing. But definitely this is not used as it is, but there are some, we can say, the cane sugar, the whatever the waste generate from this cane sugar, that can be used. Even some plant which is unwanted, that can be also used. Some even some aloe vera kind of plant and other stuff, that can be also used, which is having the dialectical property, and that can be also use some fish oil, which is generally generated with the fish, or by cleaning of that particular fish. So that type of things are used, and by using this use of that particular thing, we can use that particular materials to fabricate the certain device, which is you can say nature and nature inspired devices. Yes, this is the one example where the name of this about the plant which is having this semiconductor, that is indole, and even the substrate we can use, that is about the cell, that is people are known as some the name maybe that is all known as a silk. Even this aloe vera plant, that having this organic name, that is also having the very good dialectical property. This indigo is also having the very good semiconductor property. This one is also having very good substrate. So we can use this is as a substrate on which this layer by layer structure can be fabricated by using this dielectric material. This is a semiconductor material, and we can fabricate the device or chip like this one. So this is a good article which is published in the Materials Today. So if you are interested the full story of that particular thing, then you can go through this paper. Definitely such type of initiative must be taken by the young researcher and students. Specifically, I'm talking about the student. You have to think in this direction to change the mindset of the other people in the society. Because if we think something about the using certain new material, then we can save the environment, we can stop this e-waste problem and other stuff. So this awareness is also important. So these are the material chemical substances which are mainly responsible for this. These are the material which is mainly occurrence in this plant and other stuff, which is used as a polymer substrate and the polymer material for fabricating this device. So now onwards, I'm focusing my work towards this e-waste management. So what we are replacing, what we are you can say older material which can replace by the newer material. So we are designing certain organic molecule having the luminescence tendency, some ligand based molecule to fabricate certain complex and develop a different kind of organic light emitting device with using the cost effective and environmental friendly metal like copper and zinc, which is replaced by the other heavy metal like iridium and other stuff. So these are the work done under this project, which is sanctioned by the New Delhi government of India, that is about the scheme of young scientists and technologists. So this work is what we are presenting over here, that is published in the Luminations Journal in the 2017. So there are a huge number of these ligands are synthesized. So what we are replacing in that particular, you can say, periodic table. So what we are replacing, this is about the heavy element which is used under that particular category, where this European material is used. Sorry, European material is used. Even some other precious metal is used under that particular fabricating of organic light emitting diodes, which is iridium. Some lanthanide based material are used. Even this all materials are having a very negative effect. Even this iridium, platinum, even osmium, that are also very costly and also having some negative effect, specifically this osmium and iridium. So what we are proposing, what we are replacing this metal complexes with the other metal, which is a very eco-friendly material, which is zinc metal. So by replacing this heavy metal with the zinc, we are fabricating certain material, we design certain material and fabricate certain gadget. So here this is about the story of some certain zinc molecule. So these are the zinc material which are proposing by certain scientists, definitely. These are the progressive research and in this area. People are now focusing on that zinc kind of material. Why? Because of it are very cost effective, environmental friendly, and whatever the device generated with this material is also degradable over a period, over a certain use of a time. So these are the important aspect, and that is why we are focusing to develop certain materials in our lab and demonstrate their organic light emitting diodes and fabricate their device and assess their efficiency and other properties. So these are the very conventional compound, which is the, you can say, pioneer work appeared, definitely, which is the remarkable thing. But these all are the homoleptic complexes. So what we are proposing over here, that is heteroleptic complexes. Heteroleptic complexes is nothing but the complexes which having the two different ligands. So what we are tuning the electrical as well as optical property by tuning this two ligand, by changing this two ligand. So here, whatever the gap we are finding within this work, whatever the design of this molecule, that is complexes having the homoleptic complexes. But what we are proposing, it is about the heteroleptic complexes, which is more efficient, as well as it also having the good luminations, and this is about the data which is appeared under the publication of organic electronics. So the any molecule for our definitely some young people and for students, I will like to tell you, any material if you want to use in organic light emitting diodes, then you have to find three things. One is about the luminations of that particular material. If it showing some luminations, then it is the preliminary aspect you are the preliminary requirement is about the luminations. After that, you have to assess their electrical property by the cyclic voltammetry. You can analyze this electrical property. So then you can judge their two sites, which is known as HOMO level and LUMO level, that is the highest occupied molecular orbitals and lowest unoccupied molecular orbital. So this is about the this HOMO and LUMO level are important. From that we can get the band gap of that particular material. So definitely semiconductor material is having the smaller band gap. So whatever the band gap is also much important for this type of material. After that, we are judging the chromacity of that particular emitters. So in which area basically the emitters are emit the radiation, that is important. So here you can see this one area where it is lightly yellowish green type of area. This is about the greener type of area, and another one is about the you can say sky blue, or you can say this is between the green and blue. There is a sky blue color is there. So this is about the different color aspects are important. So what we are designing the zinc material which are representing over here, they are under this category. Definitely we are also designing some other material, they are reaching at this point, that is also a very important aspect. So when, if you can say this white color emission is important, we can fabricate, design this material which are having the tendency to, you can say, emit the light in the white region, but somehow it is really difficult to design certain molecule, and that can be also, you can say, generate by mixing of this red, green and blue emitter in certain proportion. Then we can also generate this white illuminations. So these are about the chromacity diagram. That is one of the important thing. And whatever the physical property, for photophysical property, here we are measuring, that is about the lifetime of that particular emitters, how the luminations lifetime is measured on that particular material, and this is display over here. So yes, this is about the gazette what we are preparing over here. This is about the material which we are designing in our lab, that is zinc based complexes 1 and 2. This data is showing over here. So this is about the chromacity, and what we are using, this is about the, you can say, different EQE level, and different molecules are having a different light is emitted. So our objective is to develop a white OLED by using this zinc material. That is our objective. Now, definitely, as far as we are in the progress when the milestone is concerned, and this is about the thing. This is about the EQE level. Definitely, EQE level is less as compared with the other conventional material, but definitely if I tell you the processing of that particular material, this is very energy efficient. That is the solution process. We are coat all this thing on for fabricating this device. See here, this is the pictorial representation where I showing you the green color of the LED. Definitely this is not come or on with certain plant. This is joint with the battery, and the turn-on voltage is around 3 volt, but the color is similar to that greener material which is of that particular plant. So this green color, the pure green color which is achieved, that also we can showing with this chromacity diagram. So this is about the device property with a different proportion of that particular metal. We are fabricating the different devices, and we can judge the efficiency. So the turn-on voltage is also less as compared with the previous one, and this is about the data. So this is also having this greener and other type of different color of illuminations. These are the photograph of device. Here I would like to tell you something which is definitely not, I can say, a green, but this is a good red color emitter which we publish in organic materials. that is about the iridium based molecule. Definitely this light red color, the picture is showing over here. This is not a exact red color, but definitely if you see the device that emit the radiation, that is completely red color with the good chromacity and good CIE coordinates. So this dopant is iridium based molecule, but definitely here I would like to tell you this iridium is now replaced by the Zn, and what we are fabricating the other red emitter by using the same thing, that is work in under progress. And by replacing this iridium with zinc, the redness is less, but definitely by certain device architect we can develop that red color. So if I compare, definitely this disadvantage of this metal, which is iridium based precursor, that is if I compare, that is 19,000 per gram this price is, and about we compare the Zn precursor, that is 700 rupees per kg. Okay, so you can see the difference in the cost. Even this material is environmental friendly, is also having the good yield. So if we compare the 3D and 4D lanthanide and actinide series, there are the disadvantage of that metal. There are very precious metal, there are limited resources is available. So here what we are focusing and what is my main concern to all of us, that we must have to think something different, and that must be having a more efficient, and it requires some more aspect of research and other stuff, but definitely we can come out with the material which is very newer as compared with the older one. Okay, so these are the traditional, just comparison by traditional electronics and biodegradable electronics. So just for your awareness, these are the metal are traditionally used, and the biodegradable materials which are used is about the thing. So whatever the gold, that is also in both the category. Silver is there. Now chromium, that is not good. Lead is also not good. Sometimes copper is good, but that is also the extraction process is very important. So that is all this thing, that germanium and arsenide based material. So this is about the inorganic materials which are used, and this is about the organic material which is used. So here the more focusing area, that is about the organic material, that is carbon based material, that carbon dot, carbon nanofiber, that all aspect is very important. People are reading this type of material, paper, research article, then you have to read and think something different thing to fabricate in your lab that can be easily synthesized. And what we can do something in this area, that we have to focus. This is about this carbon based technology. Then about the conjugated polymer, this is one of the important area where we are also working, and that is to develop a low band gap polymer, or you can say conducting polymer. That is also an important area where we have to focus. That is also biodegradable electronics. Then naturally occurring small molecule which is come out from plants, some edibles, that we have to focus. Then about the cellulose nanofibers, so that is also important. So these are the organic material which are replace that particular gallium nitride, gallium arsenide, metal oxide, silicon, and other bulk silicon and other stuff. So these all are limited resource. They are generate a lots of hazard, e-waste and other stuff. So if we can focusing on certain kind of material, then we can minimizing this e-waste. That is our belief, and that is our we proven at certain extent. Definitely people had to work. And also I encourage the young researcher and young people to just join this thing and accelerate their research area in this particular area. So if we compare this older one and newer one, the processing method, just a minute. The processing method of the conventional, that is about the chemical vapor deposition method, then e-beam vapor method, thermal evaporation method, lithography. This all technique are require huge energy. See, the thing is that whatever the process is used to fabricate the device can be fabricated by using this process. This process is very costly. It is also very harmful to environment because they are not energy efficient. It requires more energy. Is compared with the solution processing, that is about the you can say, you can see the our organic electronics paper where what we are fabricating that particular device with this with the use of this solution process. And finally, spin coating, screen printing, and inkjet printing, that is used. This is the technology, this is the processing technology which is very energy efficient. They are less energy is required and very simple process. Okay, so these are the process which is more useful if you want to save the environment and save the energy. Then degradable, definitely there is no chance to degrade this traditional electronics material. Definitely here what we are designing this material is degrade over a certain period, but definitely for their lifespan it must be secure that within this time it must be not degrade. That must be important. So you have to choose the material that having certain life period. So if it is having the 8 year, 7 year, 6 year, then it is okay. If it is having if they are not degraded at all for their lifelong, then it is not useful. Okay, so this one parameter which is also important. Then about the environmental effect, this is about the bad. Definitely this is about the natural thing, so it can be degraded, and that is also having the laser effect on the environment. Then energy, definitely more energy required for the fabricate as well as recycle. This aspect is the eye-opening aspect, which is energy efficient material, energy efficient devices, whereas whatever this material that they are using the lesser energy required for fabricate and degrade generally without any energy or with a smaller energy. So these are the comparison of with a certain criteria like energy, environment, degradable, process, and about the type of material. So people have to concern on this thing. Lastly, I would like to represent my this brief of our work, which is on zinc type of material. We are also doing something about the theoretical chemistry for develop this material. And finally, these are the device which is having bluish green color. This is about the pure green color, and this is about the CIE. Our objective is to develop a white LED, OLED definitely. So lastly, I would like to thank Professor Daine and IUPAC project to give me opportunity for showing this certain data of that particular project. As well as I also thankful to New Delhi DST, definitely Scheme for Young Scientists and Technologies, to provide me a financial support. I am also thankful to my head of the department to providing basic infrastructure and lab facility for this one. And finally, I thank to all for your present and listening my discussion. I am thankful to Professor Gunnule for giving me opportunity to give this discuss my research with you all people. Thank you for your attention. If any question, I am happy to answer you.
There was one question, sir.
Yes,
If
please.
I have a e-waste of computer, what is the process will I adopt? Please give an example as a common people.
Madam, definitely when you have a e-waste of computer or laptop or monitor, then definitely there is a 4 segment where it can be converted. One is about the plastic segment, that is you can say remove and or you can say recover. Then after the metal, which is semiconducting metal is used under that particular equipment, that is collected and reused. And the plastics which is not recycled, that is come out as a waste, or you can say that is generate that is non-useful plastic, or that which is not used for any kind of stuff, that is you have to throw in certain garbage. And finally the fourth aspect, which is some precious metal which is collect and use, that on that way you have to this recycle that particular thing. But definitely this is a very long process, and it require more energy to recycle this whole thing.
Thank you, sir. There is one more question, sir. Is it possible to burn e-waste in high temperature like cement kiln?
Yes.
Is it possible to burn e-waste in high temperature like cement kiln?
Yes, it is possible. It is possible, but see, there are many aspects where we have to focusing. That is multi-aspect, or there are multi-criteria where we have to analyze that particular thing. Okay.
Yeah, thank you, sir. Thank you very much. Definitely, it's a worldwide emerging problem, sir. And you have availed us with different optoelectrical waste and its management strategies, challenges for management of e-waste and alternative material, and so many things. And it was really an amazing talk. Thank you, sir, for sharing your great knowledge with us. Thank you very much.
Thank you.
Thank you, sir. Now moving ahead, feeling gratitude and not expressing it is like wrapping a present and not giving it. With this beautiful thought, I invite Dr. Nilesh Jadhav to express his gratitude in the form of vote of thanks. Over to you, sir.
Okay, sir. Madam, I am audible?
Yes, sir, you're audible.
Okay, okay. Good afternoon, one and all. It's my privilege to propose a vote of thanks on this special occasion. I, Nilesh Jadhav, on behalf of the Department of Chemistry, extend a very heartfelt thanks to the honorable speakers. I would like to thank our distinguished speakers, Professor Ponnadurai Ramasamy, sir, for making an excellent presentation on the topic of computational chemistry and its application in pharmacy and drug development. Sir, your lecture will be really helpful to the audience. Thank you, sir. I also thank our speaker, Dr. Kiran Kumar Surti, sir, for his valuable talk on the topic of greener luminescence-based molecule for optoelectrical application to overcome an e-waste problem, which make this event interesting and meaningful. I would like to express our profound gratitude to our respected principal, Dr. S.K. Naveen, sir, for his support and encouragement. Lastly, I also thank to all the participants for their active participation. Now, I declare that the today's session is over. Thank you. Thank you once again. Over to Dr. Veena Mishra, madam.
Thank you, sir. With this beautiful thought, at the end of this wonderful day, I hope you will be parting with a full package of knowledge. On behalf of organizing committee, I will take your leave and ensure you that with new topics and package of knowledge, we will meet tomorrow at the same place. Till then, take care and stay safe. Namaste.